All right, let's go on to talking about completing the square. So this is another technique for solving quadratic equations and comes in very handy, especially in factoring. This is another way you can factor, find a factor, and it's based on the idea of dealing with a perfect square trinomial. So as a little review, remember that these are special forms. And so whenever we have this form, then we know that this is a perfect square trinomial, and this would factor into a plus b quantity squared. And if we have the negative sign but it has the same form, this would factor into a minus b quantity squared. So the question is what if we don't have a perfect square on this side? What if it doesn't have the form, right? Not the complete form, right? And let's say it only has part of it, but this last term, the constant term, is not a perfect square. Well, we can manufacture a perfect square by doing what we call completing the square. So let's take this as a quick example here. Let's say this is all we have, right? So we don't have that constant term, it's gone, right? So we need to figure out what should we put there, right? So when we say completing the square, well, we know that the middle term is twice the product of a and b, right? So notice how we have x here, right? So we don't know what b is, but we can figure out what b should be, so we can add here to complete the square. Okay, so what we're going to do is, well, we know that this is twice, so we're going to divide by 2. So what we're going to do is we're going to take 10, and we're going to divide by 2, and that's going to give us 5. And now, since we already know what x is, x comes from here, so that's part of our product. So this 10 has to be 2 times b. So if we take half of 10, then the result is going to be what b should be. And so that means, in order to complete the square, we need to have 5 squared, or 25. Okay? Now here's the thing. When we complete the square, especially in an equation situation, we can't just add numbers willy-nilly, right? So in an equation situation, excuse me, let's say we have this, okay? And in an equation, whatever you do to one side of the equation, you have to do to the other side of the equation, okay? So if we're going to manufacture a perfect square here by taking half of 10 and squaring it, so let's do that again. So we're going to take 10x and we're going to add 25, right? Because if you take half of 10, that's 5, square it, that gives you 25. So we're going to add 25 here to make this into a perfect square, but then we're going to have to add 25 to the other side. Because remember, whatever you do to one side of the equation, you have to do to the other side of the equation, okay? So that's one way of doing this. And then this becomes a perfect square. Now, if you don't want to mess with one side, the other way you could look at it is if I add 25 to one side, I also can subtract 25 from the same side to make the net effect 0. So instead of adding 25 to both sides, I could do this. I could just add the 25, right, to make my perfect square, but then also subtract 25 at the same time. Okay? It's the same thing. Okay, so whether you add 25 to both sides or whether you add 25 and then subtract 25 on the same side, it leads to the same thing. Okay? However you want to do it is totally up to you. Yeah, it's the same thing. But then this here then we can deal with that because now that's a perfect square, and in this case this becomes x plus 5 squared, and then of course if we move this over, that gives us x plus 5 squared is equal to 25, and now we can solve using the square root property. Okay? So that's how the completing the square works. We'll do some examples in the next video.